How colossal is the universe? And where do we, as humans, fit within its vast expanse? Neil Turok, a renowned theoretical physicist, once painted a fascinating picture of our position in the universe. He spoke of the astronomical scale of the universe stretching from 10 to the power of 25 down to a minuscule 10 to the power of -35. A range so vast it's almost impossible to comprehend. But where do we fit into this titanic scale? Interestingly, right in the middle. The size of a living cell, the fundamental unit of life, measures roughly 10 to the power of -5. This places us squarely between the largest and smallest scales in physics. This halfway point, this meeting of extremes, is what we call the geometric mean. Consider this for a moment. We, as humans, exist in a universe that is mind-bogglingly large and yet, at the same time, incomprehensibly small. Yet we find ourselves in the middle of these two extremes. Not too big, not too small, but just right. Almost as if we're Goldilocks in the cosmic story of the three bears. It makes you wonder, doesn't it? What if we were shifted slightly towards the larger or smaller end of the scale? Would we still be able to perceive the universe as we do now? Or would our reality be vastly different? These are questions that we might never fully answer. But what we do know is this: our existence, our perception of the universe, our very reality, is intricately tied to this unique position in the cosmic scale. The universe, despite its unimaginable size and complexity, has, as Neil Turok pointed out, a certain elegant simplicity to it. And we, as humans, are an intrinsic part of that simplicity. We exist in the middle, the geometric mean, between the largest and smallest possible scales in physics. But how precise is our understanding of this scale? To answer this, let's delve into the work of Dr. William Dembski and his interactive graph, which is an astonishing tool that magnifies the universe in a way you've never seen before. This graph, found on the website Magnifying the Universe: Interactive Journey from the Smallest Particles to the Largest Galaxies, gives us a more precise measurement of the universe's scale. It measures the observable universe's diameter at approximately 8.8 times 10 to the power of 26 meters, and the Planck length, the smallest conceivable length, at 1.6 times 10 to the -35 meters. What's truly fascinating about Dr. Dembski's graph is that it points out the smallest scale visible to the human eye and the size of a human egg, both at 10 to the -4 meters. Now, why is this significant? Because this just so happens to be directly in the exponential center or geometric mean of all possible sizes of our physical reality. Imagine that. The limits of our vision, the size of a human egg, they could have theoretically been at very different positions. But instead, they sit directly in the exponential middle, the geometric mean of the universe. This isn't just a fun fact. It's a surprising piece of evidence that challenges the mediocrity principle, which suggests that there's nothing special about life, or human life in particular. So what we're seeing here isn't just a matter of numbers or scales. It's a profound realization about our place in the universe. It's about how our vision and the very basis of human life, the human egg, align perfectly with the geometric mean of the universe. It's fascinating to think that the limits of our vision and even the size of a human egg align perfectly with the geometric mean of the universe. But what role do we play in this grand design? Quantum mechanics offers a fascinating answer. It suggests that our conscious observation plays a critical role in shaping reality. Yes, you heard right. Reality at a quantum level doesn't exist until we observe it. This mind-bending concept was confirmed by a delayed choice experiment on atoms in 2015. The experiment concluded that measurement is everything. At the quantum level, reality does not exist if you are not looking at it. Furthermore, in the world of quantum physics, our free will isn't just a philosophical concept, but a fundamental part of natural laws. As the late physicist Steven Weinberg stated, humans are brought into the laws of nature at the most fundamental level. Our choices determine the probabilities in quantum mechanics. Imagine that, our decisions, our observations, shaping the universe at its most elemental level. This notion was further solidified in 2017 when Anton Zeilinger and his team, using distant quasars, closed the freedom of choice loophole in quantum mechanics. In a universe so vast and complex, it's a humbling yet empowering thought that we, as observers, play a critical role in its existence. As Richard Conn Henry, who is professor of physics at Johns Hopkins University, stated, "It is more than 80 years since the discovery of quantum mechanics gave us the most fundamental insight ever into our nature, the overturning of the Copernican revolution, and the restoration of human beings to centrality in the universe."